In section 4, we're going to look again at quadratic graphs and equations. We're going to look at the relationship between quadratic graphs and straight line graphs. Problems can be solved when you form equations. We can set up equations as graphs and we can solve these to see where the lines intersect. If we have one of the lines as a quadratic and one as a straight line graph, the discriminant can tell us the relationship between these two graphs. So if we look at the discriminant, if the discriminant is positive, that means there are 2 points of intersections. There are 2 solutions. We have the case where the straight line cuts across in 2 points, the quadratic. If the discriminant is 0, we only have 1 crossing, 1 solution. This means the straight line is a tangent to the quadratic. And if we have a negative discriminant, there are no solutions. There are no points where the lines meet. There's no point of intersection. In our first example, we need to show that the straight line is a tangent to this quadratic curve. Since they're both written in the form y equals an expression in x, we're going to equate the expressions. We're going to simplify, and then we're going to work out the values of a, b and c. We don't need to solve this quadratic equation, we just need to find the discriminant. So if we put these values into the discriminant, we get a value of 0. So this shows there's just one repeated root, so the line must be a tangent to the curve. Here is a typical exam question for you to try. Press pause, and once you've finished it, press play again to see the answers. Part A. This time we're going to rearrange equation 1 so that it's in the form y equals. Then we can equate the expressions. So equating expressions, I have this. We can now simplify to get a quadratic in x, the one we wanted from the question. In part B, we need to solve this quadratic. We always try to factorise if we can, because this is the simplest method. So we need 2 numbers that multiply to positive 5 but add to minus 6. So these are minus 1, minus 5. So we can factorise this to x minus 1 and x minus 5. So this gives us a solution of x equals 1 or x equals 5. To find the coordinates, we can put the value x equals to 1 into expression 3. We use this one because it's the easiest to find y, and we can get the value 7. When we put the value x equals 5 to the expression, we get the value y equals minus 5. So the coordinates of the points of intersection are 1, 7 and 5 minus 5. We finish with the key points from this section.